And welcome back. Okay, so we're going to look at our third video on mole calculations. This time, we're going to focus on calculations involving concentration and volume. So your first target, be able to link these three things together: number of moles, concentration of solution, and volume. And we're going to look at a couple of different types of question where you have to use this third calculation triangle. Okay, so we've already seen two calculation triangles. Let's just remind ourselves of those. The first one links mass, molar mass, number of moles. And the second is to do with volume of gases, linking the volume with the molar volume. Remember, that's always 24 decimeter cubed. And the number of moles. So we're going to now look at a third triangle. Now you can see that the first two triangles are reasonably similar. Okay, number of moles is in the same place, and we use mass and molar mass in one, volume and molar volume in the other. Okay, they are quite similar. We just interchange mass and volume. The third triangle, however, doesn't really follow the same pattern. Okay, so let's have a look at it. Okay, so in this third one, which links number of moles, concentration and volume, you can see the number of moles is in a different place. Now I'd like you to draw you to the key points that are the units. The general units of concentration is moles per decimeter cubed, and in these calculations, the volume needs to be in decimeters cubed. So you need to be able to convert between centimeters cubed and decimeters cubed. Okay, it's an essential skill to have. So you should be very good at using these triangles now, but I will write out the equations just in case you're still unsure. Okay, so just remember, the one thing you're looking for, you cover that, and then the rest of the triangle gives you the relationship between the other two variables. Now, because this triangle is a little bit different to the others, you might need a little bit extra help in remembering what goes where. The way I do this is I think about concentration. Now, the units of concentration are moles decimeter cubed. Now, another way this could be written, mole per decimeter cubed, or even, now if we take this last one here and we compare it to the equation, you can see with the units, number of moles is on top and the units for volume are underneath. Okay, so that's the way I remember this triangle. You might be able to think of a different one. Okay, so like I said, we're going to look at a couple of different types of example involving calculations, and more specifically the calculation triangle we've just looked at. Okay, so calculate the mass of hydrated sodium carbonate that is required to make up 250 centimeter cubed of a 0.1 mole per decimeter cubed solution. Quite a mouthful. So just remember to always underline the key points of question. It helps you focus on what you actually need to do. So we have our chemical, hydrated sodium carbonate. We are looking for the mass, and we have been given a volume and a concentration. You should know these are volumes and concentrations based on their units. So, just like usual, start with the information you're given. So we have got volume and concentration of our chemical. So I'm just going to draw in the triangle just to remind us. Okay, so we have concentration, we have volume. Therefore, we should be looking to work out the number of moles, which is normally the first step in the calculation anyway. So if we cover number of moles, we need to put the concentration and multiply it by the volume. So let's put in our numbers. So concentration, 0.1. Now the volume, be very careful here, because remember, our volume needs to be in decimeter cubed. Okay, in the question, it's given in centimeters cubed. So we need to convert it. You convert between centimeters cubed and decimeter cubed by dividing by 1000. I'll pop this in your calculator and it gives you 0.025 moles. Okay, so we now have the number of moles. What's the next step? Well, we're looking for mass. Okay, we have the number of moles. So think about previous triangles. We just need to multiply the number of moles which we've just found by the molar mass. So the molar mass, we have 2 sodiums, which is 46, 1 carbon, 3 oxygens, which comes out as 48. Now we have 10 waters. Molar mass of water is 18. So 10 times 18 is 180. So 286. Let's put in the units, grams per mole. Here with moles, which gives us a final mass 7.15 grams. So in this question, we have used 2 of the triangles that we've looked at, and we've gone from the liquid with its concentration and its volume, and we've converted it to a mass. Okay, so this is the mass of hydrated sodium carbonate you would need to add to make up that solution. If you're going to university, making up solutions is a critical part of that. So you need to know how to work them out. So let's have a look at a second problem, second type of problem. Excess copper 2 oxide is mixed with 40 centimeter cubed of a 2.5 moles per decimeter cubed solution of hydrochloric acid. Equation is given. It's already balanced. If the mass of copper 2 chloride produced is 5.50 grams, what is the percentage yield of copper 2 chloride? So again, it's incorporating several things we've already looked at. So let's go through the steps. Excess of copper oxide, that was the first chemical, is mixed with a certain volume of a certain concentration hydrochloric acid. So we've been given information about hydrochloric acid. You should already be thinking that we start with that. Now, if the mass of copper chloride produced is 5.50 grams, what is the percentage yield? So this is what we are looking for in the end, and we've been given information to get to that point. Now we've been given the actual yield, so we know we'll use that at the end, and then we've been given this information to be able to start us off. So let's do that. We have the volume, we have the concentration. As we saw before, we can work out the number of moles of hydrochloric acid. So remember, it's just concentration times by volume. We've been given our concentration. We need to convert our volume from centimeters cubed to decimeters cubed. We do that by dividing by 1,000. So number of moles of HCl, 0.1 moles. Okay, so just remember our conversions, our cycle from the first 2 videos, mole calculation videos. We have our moles of HCl. We are looking at copper chloride as our final answer. Now, the ratio between HCl and copper chloride is 2 to 1. So therefore, next step is to work out the number of moles of CuCl2. So we take the moles of HCl, which is 0.1. Step number 1 is to divide by 2, then multiply by 1. This comes out at 0.05 moles. Okay, so what we're going to do with these moles, we need percentage yield. We've already been given a mass, which is the actual yield. We need to work out the theoretical yield, so we need to convert this into a mass. So we have moles, as we saw in the previous example and in a previous video. To go from number of moles to mass, you multiply by the molar mass. So number of moles multiplied by the molar mass of copper 2 chloride. Stick that all in your calculator, you get 6.825 grams. Okay, in some questions that might have been enough, but in this one we need to do a final step. Okay, we need to work out the percentage yield. That is what the question is looking for. Remember, the equation for percentage yield is actual yield divided by theoretical yield times by 100. So let's just put in the numbers, which comes out at 80.59%. Normally, unless it asks specifically, you tend to give your answers to 3 significant figures, so 80.6%. So in this question, you've incorporated 3 things you've seen separately in videos. First, the triangle we've just looked at, linking number of moles, concentration, and volume. Then the triangle we did a few videos ago, linking mass, number of moles, and molar mass. And then finally, we worked out percentage yield. Okay, so you can see that questions involving calculations, often you have to think of several different steps using several of the processes we have looked at. So it's important to know all of them. So hopefully you should know the final calculations triangle. You need to know these off by heart, all 3 of them. And you should have an idea about how to tackle a variety of problems involving the calculation triangles. Specifically today, the one involving concentration, volume, and number of moles. Okay, make sure you've completed your notes, and I'll see you in class.